In this video, we're going to be working on how to divide rational expressions. But before you could do that, you should think back to the early days when you would divide fractions. When you divide fractions, you follow the following 4 steps. You keep the first fraction, change it to multiplication, and find the reciprocal of the second fraction. Sometimes you refer to that as keep, change, flip in order to remember that. And that's what you do when you divide fractions. Remember, dividing fractions is actually multiplying by the reciprocal. Once you follow those 3 steps, you then simplify the result. So take a look at the example on the right. We're going to do a very basic one, 1/2 divided by 3/4. We're going to simplify that. Remember, you keep the first fraction, 1/2, then it becomes multiplication when you find the reciprocal of the second part, of the second fraction. And then at that point, you simplify. And that's the part that I want to really focus on. You can simplify a rational expression or fractions when they're in multiplication form, as long as they have common factors in the numerator and the denominator. So here's what I mean by that. Take a look at, for example, 1 and 2, which is the first fraction, 1/2. They don't have any common prime factors, so you can't simplify 1/2. However, you might notice that 2 and 4 do have a common prime factor. 2 is its own prime factor, and 4 has 2 prime factors, 2 and 2. So they can both simplify to 1 and 2. And then that's all that can simplify, so whatever's left is what you multiply, and you get 2/3. Now the same thing is going to apply in example 2. You change it to multiplication first, and then worry about simplifying it afterwards. So we're going to keep the x squared plus x minus 12 over x squared plus 2x plus 1. Change it to multiplication and flip the second fraction, which is now x plus 1 over x plus 4. Okay, now what we're going to do is simplify each one. Now to simplify a rational expression, you do the same kind of thing you do with regular fractions, except when you're dealing with variables, you want to factor the expressions completely. So we look at the numerator of the first fraction first. It's a trinomial, so we're going to factor it by opening up our double bubble. I apologize for overlapping the question. The x squared breaks up into x and x, and 2 numbers that multiply to -12 and add up to +1 are +4 and -3. So now you have 2 factors up there, and the original trinomial is gone. Now we're going to factor the denominator. So we're going to factor that. Again, it's a trinomial, so we set up our double bubble. X squared gets split up to x and x. And 2 numbers that multiply to 1 and add up to 2 are +1 and +1. So now that that has been factored, we don't have to worry about it. And the other 2 parts of the expression, x plus 1 and x plus 4, which is in the second fraction, cannot be factored. So now we know in our numerator we have 3 factors, and in our denominator we have 3 factors. So now if there are any perfect matches, we could divide them out, just like we did in the first example. So I see right away, I see an x plus 1 here, and an x plus 1 at the top. So that's gone. Then I see an x plus 4, and another x plus 4. So I have 2 factors left, x minus 3 and x plus 1. That's actually your final answer. Now some people get misled by the fact that there's x's in each one, but those are actually 2 separate factors. Okay? So you're going to follow those steps each time. You're going to keep the first fraction, change it to multiplication, find the reciprocal of the second fraction, and then most importantly with the rational expressions, you have to simplify by factoring completely. So now that you've seen that, you're going to try the next example on your own. So pause the video and try this example, and then we'll go over the answer. Okay, so hopefully you've tried this one on your own. I'm now going to show you the solution. Remember, you keep the x squared plus 9x plus 14 over x squared minus 49. Change it to multiplication, and then flip the second fraction, which is x squared plus x minus 56 over 3x plus 6. Okay, now that you've done that, we could factor each piece. So first we're going to start with the first fraction, the x squared plus 9x plus 14. It's a trinomial, so we're going to factor into the two binomials. X and x go first. And two numbers that multiply to 14 and add up to 9 are positive 7 and positive 2. Now we're going to factor x squared minus 49. That is a difference of two squares, so we can use two binomials for that. The square root of x squared is x. The square root of 49 is 7. One of them is plus, one of them is minus. Now we're going to factor the x squared plus x minus 56. Again, it's a trinomial. So two binomials open up. X squared is split up. And the product here is negative 56 and the sum is positive 1. So the two numbers are going to be positive 8 and negative 7. And then the 3x plus 6 is a special case. It's a binomial, but it's not a difference of two squares. So to factor that, we're actually just going to take out the 3, which is the greatest common factor, and we're left with x plus 2. So everything is factored completely, and once we find all the common factors that we can divide out, we'll know what our final answer is, and that's what we'll write here. So I see an x plus 7 right away, I see an x plus 2, and I see an x minus 7. So what I'm left with is this x plus 8 and that 3. And that's it. Those cannot simplify. So my answer is x plus 8. Sorry about the handwriting. That's an x plus 8 over 3. Wow. Hold on, let me erase that. I'm going to fix that for you. That was just awful. Okay, x plus, oh, that's still pretty bad. Anyway, x plus 8 over 3. And that's your final answer. So you cannot go further than that. So again, once you've simplified each polynomial, you can factor out, divide out the common factors once you've changed it to multiplication. Okay? So follow those 4 steps every time and you should be able to divide any rational expressions.